You ever book a flight and then have that mini panic attack wondering if the departure time is in your time zone or the destination's? Yeah, that little bit of chaos is just a tiny taste of one of the biggest secret challenges for any software developer, time itself. So today we're going to dive into how Python's most powerful tools help programmers finally conquer the chaos of clocks, calendars, and time zones.
And this quote just hits the nail on the head, doesn't it? We're not talking about a small bug here. Getting time wrong can literally bring an entire application to its knees. The stakes are incredibly high, whether you're building a massive global scheduling app or just figuring out when a password reset link should expire.
So why is time such a villain in the world of code? I mean, for us, a day has 24 hours. It's pretty simple, right? Well, for a computer, time is just a number. A single, long, continuously growing number of seconds since some point in the past. It has zero built-in understanding of next Tuesday or last year. To make any sense of how we humans see time, it needs a special solution.
And that solution, our hero in this story, is Python's amazing Datetime module. And you know what the best part is? It's built right in. It's part of the standard library, which means you don't have to install a thing. It's ready to go, right out of the box, giving you a complete toolkit for wrangling time.
All right, so let's pop the hood on this toolkit. At its heart, the Datetime module gives us three fundamental building blocks. Each one is designed to represent a different piece of the time puzzle. If you can get your head around these three, you're well on your way to taming time. Okay, here are the three core tools. First, you've got date. That's just for the calendar day, year, month, day. Perfect for something like a birthday. Then you have time, which is just the time of day, hours, minutes, seconds. Think of a daily alarm clock. And then you have the star of the show, date time. It combines both of them into one super powerful object. And honestly, this is the one you're going to be using 99% of the time. So how do we actually use this thing? Well, we start by creating a specific moment in time, by passing in the year, month, day, hour, and so on. We are literally telling our program, this is the exact point in reality I care about. This is the foundation for everything else, pinpointing that one specific moment. But, just storing time is only half the battle. A raw computer timestamp isn't very useful to a real person. The next crucial step is translating that machine-friendly data into something that we can actually read and understand on a screen. And for this, we have an amazing method called string time. It stands for string format time. The best way to think about it is as a universal translator. It takes that raw, kind of ugly datetime object and turns it into a clean, elegant piece of text that you can actually show to a user. So how does this translator work? Well, it has its own special grammar, using these little format codes. You can see here, %y gives you the full 4-digit year, %a spells out the full weekday, and so on. You just mix and match these codes to build exactly the string you want. Let's see what that looks like in a real before and after scenario. Okay, so here's our raw datetime object. It's super precise, all the way down to the microsecond, which is awesome for a computer doing calculations. But if you showed this to a customer on their order confirmation page, they'd be confused, to say the least. It's just not human-friendly.
And boom! Look at the difference. By using strftime with the right format codes, we've turned that jumble of numbers into a perfectly clear, easy-to-read sentence. Now that is a much more satisfying result, don't you think?
Of course, communication has to be a two-way street, right? The module also gives us strpstrtp, or string parse time, which does the exact opposite. So think about a user typing their birthday into a sign-up form. strpstrptp is the tool that takes that text and turns it back into a powerful datetime object that your program can actually understand and work with. All right, now we get to what might be the coolest, most powerful feature of the whole module, doing math with time. This is where we learn how to do a little bit of time travel in our code. And trust me, this is where things get really fun. So, here's the key concept to grasp. There's a special object called a time delta. A time delta isn't a point in time like a datetime is. Instead, it represents a duration, a span of time. It's not a destination, it's the length of the journey. Think 90 days from now, or 3 hours and 15 minutes ago. And this is how we use it. You take a datetime object, like today's date, and you can just add or subtract a time delta from it. It's that simple. Need to know the date 90 days from now? Just add a time delta of 90 days.
This is exactly how apps calculate things like trial expirations, delivery estimates, or even that little posted 3 days ago message you see on social media. It's time delta doing all the work.
Okay, so let's pull all these pieces together for a second. These aren't just abstract programming concepts. They're the fundamental building blocks for features we all rely on every single day, in pretty much every app we use.
So here it is, your complete toolkit, all laid out. Use Datetime to pinpoint a moment. You use strftime to make it look pretty for users. You use striptime to understand what users type in. And you use timedelta to do the time travel math. If you master this workflow, you can handle the vast majority of time-related tasks that'll ever be thrown at you.
Now, before we finish, I have one final and absolutely critical warning. Everything we've talked about so far deals with what are called naive date times. Basically, they have no idea what time zone they're in. For any app with a global audience, this is a recipe for disaster. I mean, imagine a flight booking system getting the time zone wrong. That's why you must use a library like PyTZ to create aware date times. They know where they are in the world. This is essential because time zones aren't fixed. Governments can and do change them. A library like PyTZ keeps track of all of that chaos for you.
So, I'll leave you with a little challenge. An app needs to remind a user about an event exactly 1 million seconds from right now. Using the toolkit we just explored, how would you even start to solve that? Think about which objects you'd need and in what order you'd use them. That right there is how you start